Hello everyone and welcome to another mini sky tonight. So I have a follower who asked me the question about a particular show. It's called Picard that's on CBS right now. And there's one nuance about the show that they were curious of, could it happen in real life? So before we get started, huge spoiler warning. This is a brand new show that's now on CBS, and I don't want to spoil anything, and I want everybody to get the opportunity, if they want to go see it, to be able to see it. So here is your chance now to pause the video, go watch it, and then come back. Okay, for those of you who have watched it, let's move forward. So the original question was, could it be possible to have an octenary star system like shown in Picard? So as you can see in this awesome photo, they show that there are 8 stars that orbit around each other and have stable orbits. Now, in the show, they said that this was technically created, but believe it or not, there are multiple star systems out there. In fact, I often give credit to the show because as a bit of a Star Trek nerd myself, they actually do their science work. And they often reference one of the star systems that I'm going to show you that is actually indeed a multiple star system. So let's get into it. So what is a multiple star system? Well, many people don't understand that many stars often come in multiple star systems. So the thought of seeing like 2 suns rising over your horizon is very common in most stars. It just happens to be that our solar system only has 1 star. In fact, of the 2,000 star systems that are near Earth within about roughly 85 light years, over 1,000 of them are single stars. About 500 of them are binary stars, meaning there's 2 stars that orbit one another. 100 of them are triple stars. 19 of them are quadruple stars. 4 of them are quintuple. 1 sextuple, and 2 septuple, meaning 7 stars going around in this convoluted orbit. So multiple star systems are not rare. They're very common amongst our galaxy. So let's dive into some of the extremes. So like, for example, this picture I show you right here is called Alberio, which is a beautiful example of a binary star system. It's often nicknamed the Cub Scout star because one's a deep gold and the other one is a bright blue. And this is a really good double star system that you can see with a small pair of binoculars or a telescope. And so here's another example of a multiple star system. This is Eta Lyrae, which is one of the quadruple star systems. So you can see here 2 stars together and 2 stars together, and those double stars orbit each other, but then those systems go around one another. But the one we're kind of looking for is called, that we have found thus far, is that is 7. It's called New Scorpii. And it lies within this nebula right here. So this kind of little area that's part of what is known as the Blue Horse Nebula. So the bright eye of the Blue Horse is our 7-star system. In fact, let me kind of show you a diagram of it. This is what it kind of looks like up close. So as you can see, it's a very convoluted and very intricate system. So could systems like what we see in the Picard show actually occur? Yes, but it takes some bit of working to do. Now keep in mind, the only way we can get a septuple kind of star system is if it's around other stars. So like, for example, in the Blue Horse Nebula, nebulas are where stars are being born. So there's a good chance that there's another star that's forming right next to another star. And those 2 stars get in contact with each other, and it just happened to be in this one particular nebula. 7 stars were all forming at the same time, and they just got gravitationally connected to one another. So could it be possible? Yes. So what about 8? Could you have this intricate work of 8? Possibly. As you can see with the New Scorpii system, there are different types of stars. Some of them, the big bright blue stars that have a couple of solar masses. Some of them are your small little dwarf stars, and a couple of other regular stars like our sun that are intermixed. and they're at different distances. Now, keep in mind that this model is not up to scale because some of the distances are like several light years away. So you can't really see it, but it's close. So one thing to keep in mind though, you have to balance the forces in order to have a perfect orbit. Because if anything comes astray or anything other gravitational pulls it out of orbit, it no longer becomes balanced. So you have to have the right stars in the right positions in order for the system to be balanced. So what about that 8-star system? Is it possible to have stars with the right masses and the right compositions? Because keep in mind too, one of the things we have to worry about as well is this is supposed to be a stable star system, meaning like these stars don't interact in such a way that can cause, like, for example, type 1a supernovae. A type 1a supernovae, if you're familiar with the term supernova, is basically a huge explosion of a star. Now, usually when we hear the term supernova, it's the death of a star. But in this particular case, a type 1a is literally a nuclear explosion on a star. What's happening is that a bigger star is dumping material onto a tinier star, and that hydrogen compounds that are being dumped on the hotter star is literally creating a pressure cooker and going boom. So you can't have those kind of things going on in the system, because then the system will become unbalanced, and or you'll have other materials that are in the mixed, and it makes things complicated. So is it possible to have an 8? Yes, but we need to find out what kind of stars are in the system in order for it to be this perfectly balanced. Now, granted, in the show, they mentioned that these stars were intentionally put there. They were put in the exact positions and everything. Sadly, we are far from that kind of technology, and this is where science fiction starts to play into the fact. But is it possible to have this 8 system happen naturally, and say, for example, the planet that's supposed to be in the center of the system was artificially put in there? Well, let's find out. Let's take a look at the stars that were in this system. I don't know about you, but I don't get a lot of information from this picture. It looks like there's a couple of blue-white stars that are tiny. There's a couple of average size stars. So that doesn't give us a lot of information, but I mean in terms of their sizes and their masses, so it's really hard to tell. And of course, as you can kind of see in this image, they don't perfectly line up like what you see in that beautiful diagram that they show. So again, Hollywood does what Hollywood does best, fake it till you make it. I mean, it's a beautiful picture, but it's not actual truth. And that kind of breaks my heart, because one of the things I always appreciate about Star Trek is they try to keep it close to actual science as possible, and they just do a little bit hand waving when it comes to the next step. So I gotta discredit them for this, because it's like, okay, come on guys, you could at least put the stars in a perfect alignment. But nonetheless, when you look at these different types of stars, it's really hard to tell their masses. So to have these stars in perfect alignment, you have to have the right masses at the right distances. And that being said, let's assume that they are the perfect masses and that everything balances out. Is it possible to put a little planet in the center of all this? Yes, by one possibility. It's called Lagrange points in space to where the sum of, or to better explain it, all the gravitational forces equal the centrifugal force of the spinning object. For example, Earth has 2 Lagrange points that are near it that we put satellites in. So that's why we can tell that nothing's going to interact with the satellite, and we don't have to worry about the satellite having to constantly fall down into the Earth. We put them at these specific locations to where they can follow along in their natural orbit, but don't have to worry about constant gravitational tugs. For example, L1 is the Lagrange point between the Sun and the Earth. And at that point, we have the Solar Heliospheric Observatory, the one that's closest to the sun, because that particular satellite looks at the sun. So it makes sense to put it at the Lagrange point close to the sun. At Lagrange point 2, that's where we have the WMAP satellite, as well as hopefully in the future, James Webb. Now, Lagrange point 3, we have nothing there because it makes silly sense to put something on the far side of the sun where we have no direct communication with it. And it's also quite a long distance away. So it's kind of pointless to put something that far out there where it could interact with anything and we can't see it. Now at Lagrange points 4 and 5, you notice they're kind of oblonged because of just the gravitational balances between the Earth, the Moon, the Sun, and all the other planets. It creates these natural bubbles. And in those bubbles, that's where we get our Trojan asteroids, or the near-Earth asteroids, that naturally drift into these little pockets. So anytime there's a little Lagrange point or a little balance force, and if something gets into it, chances are it'll probably stay in that spot. So is it possible to, if we go back to the system, to have a tiny little planet right there in the center? Yes, it is possible. Again, assuming that these other planets are perfectly balanced and that a Lagrange point is created here in the center. Assuming that all these masses are balanced. But it's very tricky because you're talking about a tiny little planet that you have to balance all the forces, plus have the means of keeping it in that center. Because one of the problems with the Lagrange points that we have around Earth is that with these satellites, sometimes there are things that cause the Lagrange points to shape and warp a little bit, as well as things could enter into the Lagrange point and knock our satellites out of the Lagrange points. So therefore, we have to make adjustments. We have to have thrusters on the satellites to make course adjustments, to make alterations, anything of that nature to keep it in that stable orbit. On a planet, you're not going to have thrusters. Plus, the gravitational tugs to be able to keep that planet perfectly centered there when it's going in an orbit is incredibly difficult. So is it possible? Not likely. Could you do it? Maybe, but the science is very complex to be able to do it. Now, like I said, the hand wavy part is that these stars were intentionally put there on purpose, but like, as you saw in that image, I honestly think it's just Hollywood hand wavy. So that's the gist of the answer to the question. It's a kind of complex, but it gives you a rough idea that even some of the science that is in some of the shows today, some of it does have some root in truth. If you have any comments or want to debate the topic that I presented, you leave a comment down in the below. Or if you have any other topics you would like me to cover over, let me know. And until next time, stay safe, stay healthy, and as always, never stop learning. Have an awesome night, folks.